Welcome back. In this section of the series, we'll look at the reactions of ethanoic acid. Of course, from the name, we said ethanoic acid. So it means ethanoic acid will react as an acid because it is an acid. So let's look at how ethanoic acid behave as an acid. Remember, a solution of an acid in water can turn litmus paper to red. So ethanoic acid is not left out because it is also an acid. So that's an acidic property of ethanoic acid. Another one is reaction with metal. Remember, acid can react with metal, acid can react with alkali, and acid can react with carbonate. So the metal we are using in this reaction is magnesium. So ethanoic acid reacts with magnesium to give us something and something. I don't want you to memorize the products. You can just build it yourself. So here we use ethanoic acid, and it's an acid. So let's use hydrochloric acid, what we are familiar with. If hydrochloric acid reacts with magnesium metal, we are going to get magnesium chloride, MgCl2, plus hydrogen gas. So the reaction will liberate hydrogen gas. So something similar will happen in the case of ethanoic acid. So we know this one, that it's going to be hydrogen gas. So what about the second one? Remember, here, this H part goes to become H2 here. And then the Cl part combine with magnesium to become magnesium chloride. So this H from the ethanoic acid becomes the hydrogen gas, and then the remaining part of the ethanoic acid, which is CH3COO, will combine with the magnesium. So it's going to be CH3COO-Mg. Remember, we said MgCl2. So it means this one too, we have to open the bracket like this and put 2 here. So it is CH3COO2Mg. The name of the salt in reaction between hydrochloric acid and magnesium is magnesium chloride. So the name of the salt that is formed when we react ethanol with magnesium is magnesium ethanoate. So it is important to mention the state of the reactant and the product. Our ethanoic acid is in aqueous form, and our magnesium is solid. And then our salt that we form, magnesium ethanoate, this is the salt. It is also in aqueous form. And then, of course, hydrogen is a gas. Another reaction of ethanoic acid is reaction with a base or reaction with an alkali. So in this case, we are going to use sodium hydroxide as our alkali. So we have our ethanoic acid, which is aqueous, reacting with sodium hydroxide, which is aqueous as well. And then our product, if you don't know the product of this reaction, you just do like what I did last time. Hydrochloric acid reacting with sodium hydroxide will give us sodium chloride, NaCl, and then water. Sodium comes from our sodium hydroxide, and then it combines with the chlorine of the acid. The same thing here. The hydrogen part of the hydrochloric acid is this. The hydrogen part of your ethanoic acid is this. This is one that will be liberated. So our product is going to be sodium ethanoate, just like the way we have it over there. So we write our CH3COO. You know, it is H before, but sodium replaces the H. So we put CH3COO-Na. The way we did up here, you know, it is hydrogen that we have here, and then it is replaced with magnesium. So that's why it is better to write it this way, CH3COO bracket 2Mg, because we put Mg where we remove the hydrogen. So the same thing down here, we put our sodium Na where we remove the hydrogen here. So we have CH3COO-Na plus water, H2O, the way we have it down here. And then we balance the equation. Up here, we did not balance the equation. So remember, balancing the equation is also easy if you use HCl plus Mg to give us MgCl2 plus H2. So MgCl2, our Cl is 2, but our Cl here is 1. So it means we put 2 here. So the equation is balanced. The same thing, we just put 2 in front of your ethanoic acid, the way you put 2 in front of your hydrochloric acid, and then the equation is balanced. So MgCl2, and then we have CH3COO2, and then Mg. So the same thing for this. Let's see whether this one is balanced. So if we look at HCl plus NaOH to give us NaCl and H2O, this equation is balanced already. We have 2 hydrogen atoms here, and then we have 1 hydrogen and then 1 hydrogen here, balanced. 1 oxygen, only 1 oxygen atom, and then 1 sodium, 1 sodium. So this is balanced. So it means this one is also balanced. So that is a reaction of ethanoic acid with an alkali to give us salt and water. So the name of our salt here, the way we have magnesium ethanoate over there, so this is going to be sodium ethanoate. So the third reaction of ethanoic acid as an acid that we are going to consider is reaction with carbonate. Whenever an acid reacts with carbonate, we're going to have 3 products. So let's use hydrochloric acid reacting with potassium carbonate, K2CO3. So we have our hydrochloric acid. Let me write it in a better way, HCl, and then is aqueous. Our potassium carbonate, this is solid, and then when they react together, they will give us potassium chloride, KCl, which is aqueous, and then we have water as the next product, which is going to be plus H2O. Water is liquid. And then the third product, because we're dealing with carbonate here, the third product is going to be carbon dioxide, CO2, which is a gas. And then we check whether this equation is balanced or not. So HCl, KCl, we have K2 here. We have only K here. So it means we can put 2 here. So by doing that, let's check whether the equation is balanced now. So it is balanced in the case of potassium, but hydrogen, we have 2 hydrogen atoms here. But in hydrochloric acid, there's only 1 hydrogen, so we can put 2 here. So this is balanced this way. 2 chlorine, 2 hydrogen, 2 potassium, everything is balanced. So we are going to use this one to write the equation for the reaction of ethanoic acid, CH3COOH plus potassium carbonate, K2CO3. This is solid, this is aqueous, the same way. So we're going to have our KCl. We have KCl in the when we use hydrochloric acid. So we're going to have potassium ethanoate this time around. It's going to be CH3COOK, and then it is 2, so we can just put 2 here. We can put 2 here directly. So, and then you supply the remaining product, but it's going to be water, H2O, liquid, and then this is aqueous, remember, and then our carbon dioxide, which is a gas. And then we balance the equation already. The name is what they may ask from you again. The name is going to be potassium ethanoate from ethanoic acid. So that is the name of the product. So we have the 3 reactions of ethanoic acid as an acid. Reaction with carbonate to give us carbon dioxide, salt and water. Reaction with an alkali to give us salt and water, which is sodium ethanoate. And reaction with metal to give us salt and hydrogen gas. So this one will lead us to the 5th homologous series that was not really mentioned in the syllabus, but is part of the syllabus. Remember, I mentioned it at the beginning of this series. We call it ester. So let's look at esters. Esters, whenever carboxylic acid, whenever they react with alcohol, they give ester. So this is another reaction of carboxylic acid. Remember, all the reaction that we mentioned here is reaction of carboxylic acid as an acid. But this is another reaction. In this reaction, they are not reacting as an acid. They are reacting with alcohol to give us something else. So whenever carboxylic acid reacts with alcohol. They will give us ester and then water. So this one will make your life easy. Just like when carboxylic acid react with a base, it gives salt and water. Something like that as well. But the difference is that this reaction is a reversible reaction. So you have to indicate it that it is a reversible reaction. And the condition of the reaction has to be mentioned as well, which is what? Acid catalyst. So that is what IGCSE needs from you. Now, let's translate this word equation into a symbol equation. So we're going to use ethanoic acid first, CH3, COOH. When they react with ethanol, so let's use ethanol this time around. Or we can use propanol so you understand how the reaction goes. So let's use propanol. Propanol is C3H7OH. So this is propanol. So CH3 COOH. So this is our ethanoic acid. We are using propanol, not ethanol. So I'll put the OH at this side here. Remember, the reaction will give us water and then ester. So let us extract the water from this reaction first. Carboxylic acid part will give the OH. The alcohol part will give the H. OH and H will give us water. And then what about the ester? We just combine what we have left. So let's pick what we have left from the acid, this. And then we'll bring it to the other side here. So this is what we have left from the acid. And then let's pick what we have left from the alcohol. That is our propanol. So we'll bring it down here. And let's just link them together. Yeah, so this is our ester. So if you want to name this ester, it is not difficult. Before that, we said the catalyst is acid catalyst. IGCSE wants you to know the name of that catalyst. Remember, this is a reversible reaction. So the catalyst is concentrated sulfuric acid. So that's why we call it acid catalyst. Now, what is the name of this ester? So let's name our acid first. We use ethanoic acid. We react it with propanol. So our product, which is an ester, is going to be, let's look at this part. You can see I take the oxygen from the alcohol. If you look at it very well, it looks like what we have up here. You can see CH3COO. If you look up here as well, when we reacted our acid with sodium hydroxide, we have CH3COO as well, and then we call it ethanoic. And that is what we have here as well. We see that we have CH3COO. So this is ethanoic. And then the remaining part, this is, if you remember, this is like propane. You know, propane is C3H8, but this one is C3H7. So propane is this. So if it is C3H7, it is called propyl. Propyl. If it is butane, butane is C4H10. So this is butane. If it is C4H9, that is 10 minus 1, it is butyl. Ethane is C2H6. H6. If it is C2H5, it is called ethyl. Methane is CH4. If it is CH4 minus 1 with a CH3, it is called methyl. So in our case here, what we have is C3H7. So this is going to be propyl. Now, to arrange the name, you will just swap the structure. You know, ethanoate comes before propyl in the structure. If you want to name it, propyl will come first. You just say propyl and then ethanoate. So that is the name. So let's look at one other example. In this case, I will use methanoic acid, HCOOH, reacting with ethanol. Ethanol is CH3OH. This is ethanol. So remember, we said in the product, you are going to have the OH from the acid. The OH part of the acid will go, and then the H part of the alcohol will go as well. So the OH and the H of the alcohol will give us water, and then the HCO, what we have left of the acid, you put it down, so it's going to be HCO, and then we take the O of the alcohol, so I'll put it here, O, and then the CH3 that you have left of the alcohol, we'll put it here as well, CH3. So if you want to name this compound, you will name it, you will take that O from the alcohol, add it to the acid like this. So this is methanoate. Methanoate. And what we have left of the alcohol is methane minus 1 hydrogen atom. And what is that? It is methyl. The way we have it last time up there. So the name is going to be methyl methanoate. This is methanoic acid. And this is methanol, not ethanol. So this is easy, meth. So eventually we are going to have methyl methanoate. I want to add one more example. So this time around, I will use butanoic acid. So butanoic acid is going to be C3H7COOH. Butanoic acid because we have 4 hydrogen atoms, 3 and then 1, making 4. And then react with methanol. So I will use methanol. Let's use ethanol. So react with ethanol. Ethanol is going to be CH3CH2OH. So this is ethanol. And this is butanoic. Let me change the color. This is butanoic acid. So when they react, remember we said the OH of the acid will combine with the H of the alcohol. So we are going to have water from that. And then what we have left of the acid is C3H7CO. So I'll write C3H7CO. And then we have CH3CH2O from the ethanol. So we take that O from the ethanol first, put it beside this, and then to take the CH2, we arrange it backward. CH2, and then CH3. So if you want to name this compound, we have to take the O of the ethanol together with the O of the acid. So we have our, these are 4 carbon atoms. So we have butanoate, and then what we have left of the ethanol is CH2CH3, just like ethane. So it is not ethane now because this is ethane minus 1 hydrogen atom. It is called ethyl or ethyl, any way you want it. So let's group them together. This ethyl part will come first. So we have ethyl butanoate. So that is the reaction between carboxylic acid and alcohol to give us an ester.